So, Unit 4, Lesson 1, Review of Exponent Laws. Why do you think exponent notion was invented? So, well, we are familiar with the fact that the exponent tells us how many times is that base repeated, right? So when we have 3 to the 6 in an expanded form, it is 3 times 3 times 3 times 3 times 3 times 3. So it might not be useful to just write it as this expanded form, and it might be a lot easier for me to write 3 to the 6 instead. And so in other words, exponents are used as shorthand to indicate how many times is a base multiplied by itself. It's important to note that you need to have the exact same base to consider that it is that base that is repeated that a certain number of times. And it says for question 2, summarize the 5 laws you learned in grade 9 and 10. So the first rule is the product rule. So the product rule is when you have two bases that are the exact same and there's exponents on them and they're being multiplied. So when you see that, what do you do with them? Well, when the two terms are being multiplied, what you're going to do to the exponent is that you're going to add the exponent. So for example, if you have 3 to the exponent 2 and 3 to the 4, you're going to get 3 to the exponent 6. You're going to have to add the exponent. So even though it's a product rule, that product is based on the fact that you're multiplying these two powers. But when you're looking at the exponents itself, you're adding them. And it's important that you're keeping the base and you're adding the exponent. So that's product rule. Second, you have the quotient rule. So as you can guess, it's when you're dividing the power. So if you have 8m divided by 8n, well, when you're doing that, you are supposed to subtract the exponents according to the quotient rule. And you could also kind of figure that out by discovery by doing an expansion example. Okay, so for 5 to the 9 divided by 5 to the 7, well, that's like me writing 5 9 times along the numerator and 5 7 times along the denominator. So if you can picture that, you're going to have exactly how many 5s in the numerator, or you're going to have exactly 2 5s in the numerator. So that's why we have 5 to the 2. So what we're really doing is subtracting the exponents, and we got to make sure that we write the result in the numerator. For the negative exponent, what is a negative exponent? And so I wrote down on the side notes in the slides what that is and an example. But what it is essentially is if you have a to the negative a and there might be a coefficient in front of it, what you're going to do is you're going to flip it so that right now it's in the numerator form. You're going to flip it so it's in the denominator, and it's going to have a positive exponent. So in my side notes, the reason why that is because, well, if you have, let's say, 1 over 3, 5, well, that's the same thing as writing 3 to the 0 divided by 3 to the 5, because any number to the exponent 0 is equal to 1, and so 1 can also be rewritten as 3 to the exponent 0. And so I have 3 to the exponent 0 minus 5, and according to the quotient rule, I will have 3 to the negative 5. So notice that from the quotient rule, I can derive this negative exponent, this idea of negative exponents. And the reason we talk about this is because it's bad form to leave our answers in negative exponent form. So we have to know how to switch back and forth between negative exponent and to positive exponent. And how you can remember it is that they're just going to switch places between the numerator and denominator, but the sign in front of the exponent is going to change. And so for this example, what do you think the answer is going to be? Well, it's going to be equal to, well, the 2 is going to stay there. It's going to stay in the numerator because that has a positive exponent 1. So that's going to stay there. But anything with a negative exponent is going to switch from where it is. So in this case, from the numerator to the denominator. So only move the base with the negative power. Okay, next is the power of a power rule. So power of a power rule is when you have something like a to the m, but then you have brackets and you have it to the exponent n. So what are you going to do the exponents in that case, and you're gonna multiply them. You're gonna have to multiply the m and the n. So really common mistake is that when you have coefficients involved, people are forgetting to distribute that exponent into each exponent part within the brackets. We got to make sure that we do that. And so you would have, let's say, to the 4, a to the 8, b to the 12, which can be further simplified because of 2 to the 4. But I just wanted to show you up with the arrows that it is being distributed in. And lastly, you have the 0 rule, and it's a to the exponent 0 is equal to 1. And again, in the side notes, I explained it by saying, well, remember with the quotient rule, we have 4 to the 3 divided by 4 to the 3. Well, you're going to subtract the exponents by quotient rule, and you're going to get 4 to the 0. Well, that's how this equals 4 to the 0. But keep in mind, when you divide any number by itself, that is equal to 1. Back to the notes. And so here we have there will be number 3. There will be several ways to simplify expressions depending on what rule you start applying first. First answer should still match no matter what route you take. To make things easier, try to use you're going to try to use BEDMAS, and we're going to focus on the first 4 letters, and we're going to apply it on the outer exponent. Meanwhile, we're gonna also apply the negative power rule, negative power law. So these are the 2 ideas that we're gonna use a lot for these questions. So I'm gonna start with 4a. So 4a, I wrote, okay, rewrite that multiplication dot as a dot to not confuse with an x. So let me start off. So just remember that the 2 is gonna be distributed to each part within the bracket. So I have 4 squared times x squared, so that's the first part, times 4x squared. So see how I replace that x with a dot so I don't confuse it with an x. So 4 squared is equal to 16. So I have 16x squared dot 4x squared. And so I have, 16 times 4 is 64. And I want to show at least one time that these are being added. These exponents are being added based on product rule. And I'm getting 64x4. And that's question A. So for question B, I want to distribute that 3 into each part of the exponent, like so. So my first line is going to be 3 to the 3 times a d to the, negative 3 times 3 is negative 9, and then 3, and then like so. So 3 to the exponent 3 is 27, and then I have d to the negative 9, 3, and then d negative 2. So I'm going to highlight the parts that are going to be multiplied together. So the coefficients are going to multiply together, and then I have the ones with the base of d. So as my next line, I have to figure out 27 times 3, which is equal to 81. And then the d, the negative 9, and the negative 2 are going to be added. So it's like the two negatives are going to be added. And then I get 81. And then d to the exponent, negative 11. So if I leave it like that, it's bad form. It's not good to leave it in negative exponent form. So we're going to apply the negative exponent law, and we get 81. So you leave the coefficient with the positive exponent, and you're going to bring that d to the negative 11 to the denominator, and as a result, it will have a positive exponent. So for question C, I'm going to start by distributing that negative 2 into each exponent part within the brackets. When there is no exponent, that means there is an exponent of 1. Next, I'm going to write it all separately so that I don't make the mistake of distributing that 4 out to everything else, but that 4 should just sit there at the front. So I'm just putting everything separately. So far I have 4 times negative 2 to the exponent negative 2, x to the exponent negative 10, y to the exponent 0, because 0 times anything is 0, 2 to the exponent negative 3, x to the 3, and y to the negative 6. So keep in mind that the y0 is equal to 1. So I'm just putting a little rough work. And then as I keep going, I'm going to try to recognize what are the like terms. What I realize is that although I see a -2 and a 2, they are actually not like terms. So I do have to keep them separately. So I have x to the exponent -10 plus 3. Close that bracket. 2 to the exponent -3. Y to the exponent -6. Next. So I'm going to start by introducing a division line because I'm going to start having to put the terms with the negative exponents eventually to the bottom, to the denominator. So for now, I'm just going to simplify the x to become negative exponent 7 and then the rest. And then this will be all over 1. So I'm going to start moving some of the terms that does have that negative exponent. So I'm going to leave that 4 there. I'm highlighting the terms that have negative exponents. And so I'm going to start bringing it to the bottom. So I have -2 to the exponent 2, x to the 7, 2 to the 3, and y to the 6, all in the denominator. As a next step, I'm going to simplify the term. So -2 to the exponent 2 becomes a 4. The 2 to the 3 becomes an 8. I'm going to put the x7 and y6 beside it. I'm going to cancel out the 4's because 4 divided by 4 is equal to 1. That gives me 1 over 8 x7 y6 as my final answer for 1C. So part D, again, like before, I need to make sure I distribute that -2 to each part of the exponent within the bracket. So I'm showing that using my arrows, and I'm making sure I'm putting a 1 on the coefficients that look like they're missing the exponents. So I will get -3 to the exponent -2, c to the exponent -8, all over c to the exponent -1, and then 3 to the exponent -2, and c to the exponent +4. So something to consider is that the 3 and the -3, they are not, they do not consist of the same base. And so I don't want to combine them or use exponent laws in this case because they don't have the same base. I could only combine terms and apply exponent laws when it has the exact same base. So keep that in mind. So I need to consider, how do I get rid of the negative exponents? So first, I'm moving that c to the -1 to the numerator, so it becomes positive. That 3 to the -2 becomes 3 to the exponent 2, and it's in the numerator. Well, that -3 will become -3 to the exponent 2 in the denominator. The c -8 will now be c to the 8 in the denominator. And c4 will remain where it is. And then it's a matter of combining the terms that have the same bases and applying exponent law. So I notice that there is a c1 on the top and c4 on the bottom, which simplifies to c3. 3 to the exponent 2 is 9. -3 to the exponent 2 is 9. And I have c to the 8 on the bottom. And c to the 3 as well on the bottom, which further simplifies to, well, the 9's cancel out, and the c and 8 and the 3 will combine, and you'll get 1 over c11. Okay, now to question E. I'm going to distribute that 3 in within the brackets, working on my very first bracket. And when I do that, I will get, well, bracket -2, -2 to the exponent 3, times a to the exponent -6, a to the 3, all over 4, a to the exponent -4, all over to the exponent -3. So keep in mind, I could have put brackets within the -2 and get rid of the brackets on the outside of that part so that I'm really distinguishing the 3 different terms. Okay, I get -8, and I'm going to use product and quotient rule to combine these exponents. And so I'll get a to the -6 plus 3, and I'll get -4 because that a to the -4 is on the denominator. Leave that 4 in the denominator and have it all over exponent -3. I'm just highlighting the parts of how I'm possibly combining those. They all have the same base. As the next part, I have -8 and a to the exponent 1 and divided by 4. And then to the exponent of -3. So keep in mind -8 divided by 4 is equal to 2. So that simplifies. So I have inside the brackets -2a to the exponent -3. I'm going to distribute that -3 into each exponent part within the brackets. And therefore I get -2 to the exponent -3, a to the exponent -3. Keep in mind that whenever I have a negative exponent, I could put those original bases into the denominator with the new positive exponent. So 1 over -2 to the positive exponent 3 times a to the positive exponent 3. So that -2 to the exponent 3 simplifies to that a -8. So 1 over -8 a to the exponent 3. That's kind of bad form, so I want to put that negative sign in the numerator like so. So just writing here that that is bad form. So for question F, so I put exponents of 1 to the ones that are missing. You might be tempted to do distributive property like how I did with the arrows, but we're actually going to simplify within first because we're noticing that there's like a basis within inside. So it's going to be a lot easier if we work with it so that it's all simplified and then we do it. And so we're going to simplify first and then distribute that exponent in. So for example, the -2 times the 3, we're going to actually do it. All right. Okay, so I have -2 times 3 is -6. x1 plus -3 is x to the -2. y3 plus -2 is y1. That's all over with brackets of 3 divided by 6. x0 is equal to 1, so that is kind of gone. And I have y to the -1. So my next step is to make sure that I distribute that 3 into each exponent part within the numerator. So that -6 has an exponent of 1. So it's really 1 times 3 that I'm doing. So I have -6 to the exponent 3, x to the exponent -6, y to the exponent 3, and copy and paste what's in the denominators. So a few things that I'm noticing, I could do one or the other. One, I could try to combine the ones with the same basis, or I could try to move the ones that have the negative exponents. So you can do either or of the strategy. So for now, -6 to the exponent 3 is equal to -216. So I'm going to write that down. And then I have this over 6. I'm going to combine certain parts. So I have the x to the 6 on the bottom, and then meanwhile y to the 3 minus -1 because it's in the denominator. I have to subtract it by quotient rule. So I have -216 over 6, which simplifies, right? So it simplifies to -36 over 1. So I'm going to do that part first. Meanwhile, 3 minus -1 is a 4. So I'm going to start writing down -36 and then y4 all over x6. And I'm noticing that I can't simplify anymore, so I'm done for that question. So for question G, I'm gonna start by distributing that -1 into each exponent part of the first bracket. And I am showing that with my arrows, and I will get 5 to the exponent -1, k to the exponent -3, and then -5, and then Actually, it's all over k because I just want to get rid of that -1 exponent right away. As a next step, I'm going to rewrite those ones with the negative exponents all to the bottom. So you could have actually skipped that and gone to this step right away. So 1 over 5k3 minus 5k, 5 over k. So this reminds me of the reciprocal unit, and I want to use the LCD, and I recognize it's 5k3. I'm going to multiply the second term on the numerator and the denominator by k squared so I can get it to be 5k3. So I have to actually multiply by 5k squared on the numerator and denominator to get 5k squared. And so when I do that, I will get 1 over 5k3 minus 25k squared all over 5k cubed. So keep in mind that you can actually put this together all in the numerator as 1 minus 25k squared divided by 5k3. Meanwhile, I'm putting a recall message between 1 over 3 plus 1 over 3, and I'm showing you that the numerators will add to be 2 over 3. And finally, back to my conclusion, all over 5k. Okay, so for h, you might be tempted to distribute that 2 into the brackets like we've been doing. But notice that it is a binomial inside. So you need to ask yourself whether we could do that or not. So no, we can't do that, and we have to actually FOIL it out instead. So it's a binomial, therefore we need to use FOIL. And so I'm going to have equals -2x cubed plus x to the -1 close brackets, -2x cubed plus x to the exponent -1. Keep in mind I can write my x to the -1 in fraction form, so I'm going to do that next. -2x cubed plus 1 over x, close brackets, -2x cubed plus 1 over x cubed. So recall I'm going to use the binomial expansion to help me simplify this. And so I'm using a plus b squared equals a squared plus b squared, or not that, a squared plus 2ab plus b squared to help me FOIL this out. And so I should have as a next step bracket -2x cubed squared plus 2 bracket -2x cubed bracket 1 over x bracket 1 over x bracket squared. Next, I will have, well, -2 squared is 4. Okay, so I'll have 4. I'll have 4 x to the exponent 6, because 3 times 2 is 6, plus, 2 times -2, that portion is actually equal to -4. So I'm going to write -4. And then x3 divided by x is x squared. And then plus 1 over x squared is equal to 1 over x squared. So with that, just be careful that you realize that that is not all over x squared. Okay, I'm going to recognize that the LCD is x squared, so I'm going to put all of that as x squared, so I have to purposely make that happen. So the other first two terms are all over 1. I'm going to multiply the top and bottom by x squared so that I can put it all over x squared. That's what I meant by it's not, everything's not by all over x squared. You have to make it happen. And so there's another step of considering the LCD and showing this work. Okay. So we have 2 over x, if we rewrite that first part, and divided by x to the -1 plus x. I can also rewrite the things in the brackets with 2 over x divided by 1 over x plus x. Okay, so I'm going to find the LCD of the second bracket, and the LCD of it is going to be x. So the second term has a denominator of 1, so I'm going to multiply the top and bottom by x. And then I'm going to have 2 over x divided by bracket 1, all over x, and then 1 plus x squared, close brackets. As a next step, I'm going to multiply by the reciprocal. So I have 2 over x times x over 1 plus x squared. So I have to have brackets on my binomial on the bottom. Meanwhile, I notice that some terms cancel out, so I show that. And then I will have 2 over 1 plus x squared as my final answer.